The marine predator that ruled the food chain. Without teeth. For most of the history of life in the ocean, one rule seems almost universal. The most powerful predators carry the most dangerous teeth. Long rows of razor-sharp blades designed to slice through flesh, crush bone, and hold struggling prey with unstoppable force. From sharks to marine reptiles to the giants that swim today, the top of the food chain is usually defined by jaws filled with teeth. But far back in Earth's distant past, long before whales or sharks dominated the seas, there existed a creature that completely ignored that rule. It ruled the oceans with terrifying authority. It could crush armored prey that other hunters could barely damage. And it did all of this without a single tooth in its mouth. That predator was Leedsichthys, one of the most extraordinary and intimidating animals ever to swim through Earth's ancient oceans. To understand why Leedsichthys was so unusual, it helps to travel back nearly 370 million years to a time known as the Devonian period. This era is sometimes called the Age of Fishes because marine life was expanding in incredible ways. The oceans were filled with early fish species, evolving new shapes, sizes, and survival strategies. Coral reefs spread across shallow seas, creating complex habitats where animals could hide, hunt, and compete. Strange armored creatures crawled along the seafloor. Primitive sharks had begun appearing, experimenting with body designs that would eventually make them some of the most efficient predators in history. Yet the oceans of the Devonian still lacked many of the giants we recognize today. There were no whales gliding through deep water, no massive squid patrolling the darkness, and no modern sharks slicing through waves with rows of triangular teeth. Instead, the seas were dominated by a different group of animals entirely. Among these creatures were the placoderms, an ancient class of armored fish that developed thick plates of bone covering their heads and upper bodies. These bony shields acted like natural armor, protecting vital organs from attack. Most placoderms were relatively modest in size, feeding on smaller prey or scavenging along reefs. But within this group, one species evolved into something far more formidable. Leedsichthys grew to massive proportions, reaching lengths that may have exceeded 8 or 9 meters. Its body was powerful and streamlined behind the armored head, giving it both strength and mobility. But the most striking feature of Leedsichthys was the structure of its jaws. Unlike modern fish or sharks, Leedsichthys did not have individual teeth embedded in its mouth. Instead, its jaws were formed from sharpened bony plates that acted like blades. These plates met together with precise alignment when the mouth closed. Over time, the constant motion of opening and closing kept their edges sharp, creating a natural cutting surface. Imagine two enormous steel blades sliding past each other with crushing force. That is essentially how the jaws of Leedsichthys worked. Rather than relying on dozens of teeth to tear flesh piece by piece, it used these bone edges like shears, slicing through prey with devastating efficiency. And the structure of its skull reveals just how powerful this system was. The head of Leedsichthys was encased in thick armor plates that formed a protective helmet around its brain and jaw muscles. These plates were fused together in a way that provided both strength and stability during biting. Beneath this armor, enormous muscles connected the lower and upper jaws, allowing them to close with tremendous force. Recent biomechanical studies suggest that the bite of Leedsichthys may have been among the strongest ever recorded in a vertebrate of its time. Some estimates place the pressure of its bite at levels comparable to, or even exceeding, famous land predators such as Tyrannosaurus rex. For an animal living hundreds of millions of years before the dinosaurs appeared, that level of power is astonishing. But strength alone does not make a successful predator. Speed and timing also matter, especially in water where prey can move quickly in any direction. Leedsichthys had another advantage hidden in its jaw design. The joints of its skull allowed the mouth to open extremely rapidly, creating a powerful suction effect as water rushed inward. This sudden movement could pull prey directly toward the jaws before it even realized the danger. Within a fraction of a second, the bony plates would snap shut, trapping the victim in a crushing grip. For smaller animals, this meant instant death. For larger prey, it meant catastrophic injury that ended the struggle almost immediately. The Devonian oceans were filled with creatures that relied on armor for protection. Many fish developed thick scales or bony plates covering their bodies, and creating natural shields against predators. These defenses worked well against hunters that relied on piercing teeth or slower attacks. But Dunkleosteus approached the problem differently. Its jaws did not attempt to pierce armor in the traditional sense. Instead, they cut through it with overwhelming force. The blade-like edges of its jaw plates could slice through bone and shell in ways that other predators simply could not match. Prey that evolved thicker defenses often found those defenses useless against the crushing power of Dunkleosteus. Fossil evidence shows that Dunkleosteus was not picky about what it ate. Its remains have been discovered alongside fragments of other armored fish, suggesting that it regularly preyed on animals protected by similar bony plating. In some fossils, the marks left by its jaws can still be seen, are clear signs of the immense pressure applied during feeding. There is also evidence that Dunkleosteus may have been capable of cannibalism, attacking members of its own species when the opportunity arose. In an ecosystem where food could be scarce, even a giant predator might turn on rivals to survive. The presence of such a dominant hunter reshaped the entire food chain of the Devonian seas. Smaller fish evolved behaviors to avoid open water, where Dunkleosteus could strike without warning. Many species remained close to reefs or complex environments where obstacles might slow a large predator. Others developed faster swimming abilities to escape sudden attacks. But despite these adaptations, Dunkleosteus remained one of the most feared creatures of its time, or its armor protected it from retaliation while its jaws ignored most forms of defense. For many animals in those ancient oceans, survival depended on never crossing paths with this giant. One reason Dunkleosteus was so effective is that it combined multiple advantages in a single design. Its armored head acted like a shield, reducing the risk of injury during encounters with prey or rivals. Its powerful muscles allowed it to generate extraordinary bite force. Its jaw plates stayed sharp through constant use, eliminating the need to replace broken teeth. And its body behind the armored head remained streamlined enough for active swimming. Evolution had assembled these features into a predator that required little refinement to dominate its environment. And the success of Dunkleosteus also reveals something important about how evolution experiments with different solutions. Modern oceans are filled with predators that rely on teeth, but teeth are only one way to capture and consume prey. By replacing individual teeth with sharpened bone plates, Dunkleosteus created a system that was both durable and brutally effective. It could slice through prey without worrying about losing teeth or dulling them over time. Each bite reinforced the cutting edges, keeping them functional for the next attack. For millions of years, Dunkleosteus ruled the seas as one of the top predators of the Devonian world. Its presence defined the upper limit of the food chain in many marine ecosystems. Few animals were capable of challenging it directly. Even other large predators had to contend with its armor and devastating bite. The oceans were vast, but in the regions where Dunkleosteus lived, it was one of the final threats any creature would ever encounter. Yet even the most dominant species eventually faces challenges beyond its control. Near the end of the Devonian period, the Earth experienced dramatic environmental changes that reshaped marine ecosystems across the planet. Shifts in climate, sea levels, and ocean chemistry caused widespread extinctions among many marine species. Coral reefs declined, habitats disappeared, and entire groups of animals vanished from the fossil record. The placoderms, including Dunkleosteus, were among the creatures that failed to survive these transformations. Their disappearance opened the door for other predators to rise, saw sharks continued evolving, refining their flexible skeletons and rows of replaceable teeth. New fish species appeared with improved speed and agility. Over time, the structure of marine food chains changed completely, eventually giving rise to the familiar predators that dominate modern oceans. But for a long stretch of Earth's history, before those later hunters perfected their designs, Dunkleosteus stood at the top of the marine world. Its story challenges the assumption that apex predators must follow the same pattern. Dunkleosteus did not rely on rows of razor-sharp teeth to claim its dominance. Instead, it relied on a design built around crushing power, armored protection, and cutting bone plates that functioned like natural blades. It proved that evolution can achieve the same outcome through entirely different paths. And in the distant Devonian seas, long before the first dinosaurs walked on land, this enormous armored fish controlled the upper levels of the food chain. Prey animals had few defenses against its bite, and even fewer chances of escape once it attacked. Its success did not come from speed alone or size alone. It came from a design so efficient that it could dismantle nearly anything in its path. Dunkleosteus remains one of the most fascinating predators ever discovered, not just because of its size, but because it broke the rules we expect from ocean hunters. It shows that dominance in nature is not always about having the sharpest teeth or the fastest body. Sometimes it comes from a combination of features working together with brutal efficiency. And in the ancient seas of the Devonian, that efficiency made Dunkleosteus the undisputed ruler of its world. What makes Dunkleosteus even more fascinating is how early it appeared in the history of complex predators. When it ruled the oceans, the idea of a gigantic apex hunter was still relatively new in evolutionary terms. Life had already existed for hundreds of millions of years, but ecosystems were only beginning to support animals that occupied the very top of the food chain. Many species were still experimenting with new body designs, trying different combinations of armor, speed, and feeding strategies. In that experimental world, Dunkleosteus emerged as a solution that worked almost too well. It was powerful enough to attack nearly anything it encountered, yet durable enough to survive encounters that would cripple other predators. This combination allowed it to sit comfortably at the highest level of the marine hierarchy, shaping the behavior and evolution of countless species around it. Another reason Dunkleosteus dominated so effectively was its sheer presence in the water. A creature of its size moving through the Devonian seas would have created a powerful visual signal to other animals. The armored plates around its head formed a massive silhouette, unlike anything else swimming at the time. For smaller fish, the sight of that broad skull and opening jaws likely triggered immediate escape responses. In modern oceans, prey animals often rely on recognizing the outline of dangerous predators such as sharks. The same principle may have applied during the Devonian period. The distinctive shape of Dunkleosteus may have become a universal warning sign in the marine world, a signal that danger had arrived and that survival depended on reacting instantly. The ecological impact of such a predator goes far beyond the animals it directly killed. Apex predators influence entire ecosystems by controlling population levels and altering the behavior of other species. When prey animals must constantly remain alert, they change where they feed, how they move, and how they gather in groups. These changes ripple through the food chain, affecting smaller organisms and even the structure of habitats like reefs and seafloors. Dunkleosteus likely played this role in Devonian oceans, acting as a stabilizing force within marine ecosystems. Even though Dunkleosteus eventually vanished during the mass extinction events near the end of the Devonian period, its legacy remains important for understanding the evolution of predators. It demonstrated that extreme specialization could dominate entire ecosystems for millions of years. Long before sharks refined their cutting teeth, and long before marine reptiles evolved into swift ocean hunters, Dunkleosteus had already proven that an efficient design could control the seas. Its success showed that the path to becoming an apex predator does not follow a single formula. But the story of predators evolving to conquer different environments did not end there. As millions of years passed, new creatures would rise with abilities even more unusual. Some would hunt in the oceans while also moving across land, blurring the boundaries between ecosystems. And eventually, the world would see predators that mastered not just water or land alone, but the shifting spaces between them.